How to debug non-deterministic bugs using GDB. Have you ever faced a bug that just won't show up when you want it to? Non-deterministic bugs can be tricky because they don't always happen under the same conditions. They can be caused by things like timing issues or unexpected inputs. Debugging these types of bugs with the GNU Debugger, commonly known as GDB, requires some specific strategies. Let's break down how you can tackle these elusive bugs effectively. First, make sure to compile your program with debugging symbols enabled. You can do this by using the -G flag when you compile. This allows GDB to give you detailed information about your source code while debugging. Since non-deterministic bugs can be hard to reproduce, avoid restarting your program manually. Instead, take advantage of GDB's features to automate and control the execution. One effective method is to set breakpoints at locations in your code where you suspect the bug might be hiding. You can also use conditional breakpoints, which will only stop the program when certain conditions are met. This helps you isolate the bug when it finally shows up. Additionally, you can attach commands to these breakpoints that will execute automatically, like printing the values of variables or restarting the program. Another useful tool in GDB is the Watchpoint. Watchpoints allow you to monitor specific variables or memory locations for changes. When the data you are watching changes, GDB will pause execution. This is particularly helpful for tracking down unexpected changes that lead to non-deterministic behavior. Now, let's talk about reverse debugging techniques. While GDB doesn't fully support reverse debugging, you can use commands that allow you to step backward or restart execution automatically. There are tools like Undo's Live Recorder that can work with GDB to capture your program's execution and replay it. This feature can help you trace back through the program's state changes, even when dealing with non-deterministic factors like thread interleaving. Controlling your input and environment is also key. Since many non-deterministic bugs arise from unpredictable inputs, try to capture and replay these inputs consistently. You can use recorded inputs or mock external dependencies to reproduce the bug reliably while using GDB. Automating your debugging sessions can save you a lot of time. GDB scripting allows you to automate repetitive tasks, such as setting breakpoints and running commands. This is especially useful when dealing with bugs that appear sporadically. Lastly, be aware that non-deterministic bugs often stem from concurrency issues, like race conditions. GDB can attach to multiple threads, but debugging these requires careful inspection of thread states and shared memory. Use thread-specific commands to switch context and monitor how different threads are behaving. In practice, you might start by setting a breakpoint at a suspected failure point. Attach a command to print relevant variable states, and then use GDB to restart the program automatically until the bug triggers. If you have access to reverse debugging tools, they can help you step backward from the failure to pinpoint the root cause. Remember, non-deterministic bugs can be challenging due to their reliance on timing and external factors. By combining GDB's capabilities with careful control of inputs and environments, you can improve your chances of isolating and fixing these tricky bugs.